So, my fellow students of statistics, today's topic is what's going to happen to our means and variances slash standard deviations when we manipulate our numbers. Here are two distributions. We have two random variables. The first one, this could be everybody in school, or it doesn't really matter, it's made up. It could be everyone in the state or the country. This is the number of Redbox movies rented per month by some group of people. And we just have to keep it simple. 0 through 3 is our possibilities with nice basic probabilities in there. Now I have found the mean and variance of this distribution, which is what the last video was about. It would have been, in my chart, in my calculator, multiplying them and adding them and squaring them and all that good stuff to find this mean and this variance. All right, the average person, on average, we rent 1.1 movies from Redbox in a month. The variance is 1.09. Remember, when you're finding standard deviation, the step before you square root is the variance. The rules for today are in terms of variance. So just realize that's the way the rules are set up to make them a little simpler. But anytime you have variance, if you need standard deviation, you'll just square root it, and vice versa. If you need variance and you have standard deviation, then you'll square it. All right, so just don't let it bother you that the rules are in terms of variance. All right, there's some mathematical reasons why that's a little simpler. So we have a different distribution, different variable y for the number of Netflix movies watched per month. And it's similar with 0 through 3, just to keep it simple. And there are the mean, variance, and standard deviation. And the little square on those, that's what indicates that that's the variance. All right, so our questions of the day. What's going to happen if we adjust our numbers? What if everybody in the school got a free Redbox coupon and they all increased their number by 1? So everybody who had 0 had 1, and 1 had 2, and so on. Or what if everybody ups their Redbox activity by 50%? So we multiplied by a number. Or what if we wanted to know how many movies combined get watched in a month? Those are the three questions. So write down these questions. This is going to be our three topics. What happens to means and variances if we add to each number / subtract, or multiply each number, or combine two? These are the three questions that today's formulas are going to answer. Now notice, I was not given a big list of everyone's name with how many movies they rented from either of these sources. I just know the mean and standard deviation. I don't even really need to work these problems, and a lot of the problems you work won't give you the chart. I just wanted you to see it for some visual, but all I need to know is what mu and sigma squared are, what the mean and the variance are, in order to use these rules. All right, so let's get into it here. Let's start with means. Here is our first rule for means. U sub a plus bx. That should look kind of familiar. We did something similar to this early on. Is equal to a plus b mu x. And that's, it looks more complicated than it is. What this means is if everybody increases their movie watching on Redbox by 1, then our average is going to go from 1.1 to 2.1. Makes a lot of sense. All right? Everybody goes up 1, then the average is going to go up 1. If everybody multiplies their numbers by 2, then we are going to multiply by 2, and we would get 2.2. And both of those things could happen. If everybody doubled and then added 1, we would take our mean, we would double and add 1. All right, so this just means if you multiply each individual number, even though you can't see those numbers, you're going to multiply your mean. If you add to each of those numbers, then you're going to add to your mean, okay? So what about means for combining? if my next question were how many movies do we average per month, then that would be easy. We would add 1.1 and 1.9, and we would get 3. So on average, we watch 3 movies per month, and with a combination of Redbox and Netflix. So these mean rules make a lot of sense, right? If you add to the numbers, you add to the average. If you multiply each number, then you multiply the average. If you combine two, all right, if we create kind of a new random variable, let's say we identified Z as the random variable, total movies watched on either Redbox or Netflix, then the average value of Z would be the averages of X and Y added together. So those kind of just make sense. The ones for variance are a little more complicated. Okay, so here's number 1. For variance, the way it's stated in your book, if X is a random variable and A and B are fixed numbers, then the variance, which is sigma squared, of A plus BX, meaning we take all of our individual X values, which would be everybody's number through the whole school, and we either multiply or add or both to all those numbers, then what's going to happen to the variance? Well, the variance is going to be B squared sigma squared X. Notice that this A showed up nowhere on the right-hand side. Think about what that means. That means we could add to everybody's value, and all it's going to do, like we've talked about earlier, is going to shift down the axis, but it's not going to get any more or less spread out. Okay, so let's look at an example. If we're talking about Netflix, the variance is 1.29. If everybody increases by 1 movie per month, then we're still going to be at 1.29. But let's say everybody doubles, right? They double their output. Well, if they double, the variance is not only going to increase, but it's going to increase by a factor of 4 because of this square. So if B is 2, our variance actually turns into 4 times what it originally was. All right? So there is variance if we're doing adding and multiplying to the numbers. Okay? Now we've got a bunch of formulas that we have to sort through. Don't worry, they're worse. They are not as bad as they look. The variance for 2 random variables put together, as in, what if I want to know about how many movies total we are watching? What can I do with my variances? Well, if I combine those two, then yes, I can combine my variances. All right, so I add together 2 random variables, my variances will add. What if I subtract them? And I have some sort of question about how many more, my distribution is how many more Redbox we watch than Netflix or vice versa, for some other more relevant set of 2 random variables if we needed to subtract them. Doesn't make a whole lot of sense for this particular example, but it will for others. Okay, this might look like a typo, and I am prone to typos, but plus, all right? If we subtract our 2 random variables, we are still going to increase our variance. We're going to add those 2 together, whether we combine them by adding or subtracting. All right, that just kind of tells us we're not going to get any less spread out if we combine 2 random variables. We are going to get more spread out, even if we are subtracting them. It doesn't matter if we're adding them or subtracting them. All right, here's the last one. This is where it kind of turns ugly, but again, don't worry, it's not that bad. This is for independence. If our 2 random variables are independent of each other. Now, I would say that our 2 random variables are not independent of each other. How many movies I watch on Redbox has something to do with how many I watch on Netflix. Right? If I've got the best Netflix subscription and I can watch that all day, I'm probably not going out to Redbox very much and getting my $1.29 movies. If I don't have Netflix, then I'm more likely to go to Redbox. So these 2 things have some sort of correlation. So what if they are not independent? If there is some amount of correlation between my two random variables. This is what it's going to look like. If I'm adding two together, the variance of x plus y is going to be the variance of x plus the variance of y plus 2 rho, that's a little kind of lowercase p, but in Greek it's called a rho, times the standard deviation of x times the standard deviation of y. So if they are dependent, we have to throw this extra term on the end. Don't worry, you're not going to have to calculate, what rho is. If they are dependent, the question will say the correlation between these things is 0.8, and you're going to plug 0.8 in. All right, this is going to be a real plug and chug type thing if we're using these formulas. The subtraction one, by the way, let's clone that and make some changes. It's going to be faster just to write it because it's so similar. All right, so if I'm subtracting 2, the variance of the difference of my two random variables is the variance of x plus the variance of y minus 2 rho sigma x sigma y, standard deviation of x and y. So make a note, rho, first of all, that's what it's called, and it equals correlation, and it's going to be given. All right, so that's all you really need to worry about those. So let's summarize, and then we'll call it a day. If we want to put together two random variables, the means you can just add. All right, that's here. Combine two random variables, like how many movies do we watch total on Netflix and Redbox? We're just going to add the two means together. If we want to put together two random variables, we're going to use one of these. By the way, I forgot to label these dependent. And you'll know you're dealing with dependent random variables when it says, here's the correlation. If that's the case, we use these formulas. The bottom two are going to be actually the easiest problems because you just plug and chug. The top two might require a little more thought, but the one thing to remember is if you're subtracting x and y, you still add the variances. So what if we multiply or add? All right, what if we take our Netflix and everybody changes their Netflix plan so they have twice as much? Or what if they get one additional, what if Netflix changes and everybody gets one additional movie? If we're adding and multiplying. Well, the means, we're just going to add and multiply just like we did to each individual number. If we double all of our numbers, we double our mean. For variance, you can add anything you want to every number, and that same distribution, think of it in terms of a histogram or if I have a graph that looks like this, and I add to it, all I'm doing is I'm taking this graph, sliding it down the axis, and it's still not changing shape. Right? It's relative to the other bars, they're all still in the same spot. They just moved down the axis a little bit. They're no more or less spread out. But if I multiply, my variance is not only going to multiply, but it's going to multiply by that amount squared. So if everybody doubles their movie watching, then our variance is going to multiply by 4. Okay, so I didn't have time for any other good examples, but just get this down and we will worry about the applications once we get to class. Right? If you've enjoyed, I'm out.